Hello, good morning dear students. Welcome to Interactive Virtual Class Nagaland once again. I hope all of you are doing well. Yes? Alright, so today we will continue with the chapter metals and non-metals. Okay? So let us see here. Okay? Here we see a woman taking a beautiful copper vessel. Yes, it is shiny, it is beautiful. When you look around, you will see that all these utensils are also shiny and beautiful. Yes. So after a few days, what happens? Okay, after a few days, we see that the copper vessel has become dull. Yes, it's not shiny anymore. The color has changed a little bit. Yes, it has become dull. It is not shining anymore. Yes, so students, have you observed this even in your home? Yes, do you know why? We will learn that in today's class. Okay, so here we see that all the utensils, the copper vessel, it is not shiny anymore. Then the woman, okay, took the copper vessel and washed it using steel wool. Okay, she brushed it. Then again, let us see after washing it what happens to the copper vessel. Okay, so again after washing it, we see that the copper vessel is again now shiny. Yes, students. So why do you think this is happening? Okay, why do you think this is happening? Let us see. Okay. Again, another example here. We have an iron gate. Yes, we have an iron gate. It is shiny and it looks pretty. Okay, but what happens after some time? Okay, after it is kept, after it is made and left it outside for a very long period of time. Okay, after it faces the wind, rain, okay, and different types of weather, what happens to the iron gate, which is new and shiny? Okay, when it is new, it is beautiful, it is shiny, it is clean, but what happens after some days? Okay, let us see. So after time passes by, okay, or after so many days or years, what happens to the iron gate? Let us see. We see that it has become rusted. Yes, it has become rusted. So why do you think this is happening? Okay, we see that the copper vessel, at first it was shiny, but it is not shiny anymore after it is left for some time. And in case of iron gate as well, it was shiny, but after some time, after some months or years, it has become rusted. So why do you think this is happening? Okay, this is happening because of their chemical properties. So in our previous class, we have discussed about physical properties of metals and non-metals. Yes, students, if you can remember, we have also differentiated between metals and non-metals depending on the physical properties. So in today's class, we will discuss about the chemical properties of metals and non-metals. Okay, so let us see. Here we see that copper vessel, at first it was shiny, but it is not shiny anymore. And the iron gate was shiny, but after some time it got rusted. Yes, students. So why is this happening? Let us see. Okay, we will find out in today's class. So to find out that, let us first perform an activity. Okay. So we have a burner here, and we have magnesium ribbon. Okay, magnesium ribbon is made of magnesium, which is a metal. Okay, so let us take the magnesium ribbon and see what happens when we burn it. Okay, so hold the magnesium ribbon with a holder and bring it near the burner. It burns. Yes, it burns in the presence of oxygen. Now we have studied in our lower classes that combustion means burning, and for combustion to take place, oxygen is necessary, right? So here magnesium ribbon burns in the presence of oxygen. If the air is not present, if the oxygen is not present, this magnesium ribbon will not burn. So here we see that magnesium ribbon burns in the presence of oxygen and give us these ashes. Yes. So here this is the product. Okay, and the product is magnesium oxide. So the reactants are magnesium ribbon and oxygen, and the product is this magnesium oxide. So here we see that when magnesium, okay, magnesium is a metal. When it reacts with oxygen, it forms magnesium oxide. Okay, so magnesium reacts with oxygen to form magnesium oxide. These are the reactants and these are the products. This is the products. Okay, so remember students, when magnesium reacts with oxygen, it forms magnesium oxide. Another activity, let us see here. Aluminium, sodium, lead, zinc. Okay, all these are examples of metal. Yes, all these are metals. Aluminium, sodium, lead, zinc, all these are metals. Okay, so when aluminium is burned, we will see this white color flame. When sodium is burned, we will see this color flame. When lead is burned in the presence of oxygen, it will also produce flame. And when zinc is burned, then it will also produce flame. Okay, so here we see that these are the examples of metals. When they are burned, they produce flame, some flame. Yes. So aluminium reacts with oxygen to produce aluminium oxide. Sodium reacts with oxygen to form sodium oxide. Lead reacts with oxygen to form lead oxide. And zinc react with oxygen to form zinc oxide. Okay. So when we look at this, we see that when metals are burned in air, okay, or when metals react with oxygen, okay, we see that all these are examples of metals. All this, the one in yellow box are all metals. So metals, when it reacts with oxygen, it gives metal oxide. Okay, remember this students, when metals reacts with air or when metals reacts with oxygen, it produces metal oxide. So when metals are burned in air, that is, when metals react with oxygen, it produces metal oxide. Okay, so this is the one chemical property of metals. Okay, when metals react with oxygen, they give metal oxide. Alright students, we have the first question for today. Please get your rough devices ready. The question is, a metal M on burning gives a dazzling white flame and changes to a white powder N. Identify M and N. Okay, I'm giving you 15 seconds for this question students. Your time starts now. A metal M on burning gives a dazzling white flame and changes to a white powder N. Identify M and N. Alright students, your time is up. And yes, we have just seen in our activity that when magnesium burns, or a metal magnesium on burning will give a dazzling white flame and changes to a white powder and magnesium oxide. So here the correct answer is option A, that is M is magnesium and N is magnesium oxide. Know this, okay? Know this. Different metals show their own characteristics flame color when burned in air. Okay, so just like when magnesium burns, it gives white flame. Okay, so different metals show their own characteristic flame color when burned in air. Okay, so let us see some examples here. We see that these are some of the metals like lithium, potassium, rubidium, cesium, calcium, thorium, barium, calcium, titanium. All these are examples of metals. And when they burn, okay, in air, they will produce their own, or they will give their own characteristic flame color. So we see different flame color for different metals. And these salts are used, okay, the salts of these metals are used in crackers, and that is why we are able to see different beautiful colors when we burn firecrackers, okay, because these firecrackers, okay, are made from the salt of different metals. Now potassium, we have potassium, we have sodium, and we have lithium. So these are also some examples of metals. And these metals, they undergo rapid oxidation. Okay, they undergo rapid oxidation. So let us see how. Okay, lithium, sodium and potassium, these metals such as potassium and sodium react vigorously when kept in open air. Okay, hence to protect them they are kept immersed in kerosene oil. These metals they undergo rapid oxidation, so when they're left open in the air they will react vigorously with the air. Okay, and that is why we cannot keep these metals in an open air, we have to store them in kerosene oil. Okay, so remember this, students. Okay, this is very important. Metals such as potassium and sodium react vigorously when kept in open air, and that is why in order to protect them they are kept immersed in kerosene oil. Okay, so potassium and sodium they undergoes rapid oxidation. Aluminium and magnesium they undergo slow oxidation. Okay, so at ordinary temperature the surfaces of metals such as magnesium, aluminium, zinc, lead, etc. are covered with a thin layer of oxide. Okay, the protective oxide layer prevents the metal from further oxidation. So let us see this. Here we have aluminium. Yes, here we have aluminium atoms. Now these aluminium atoms will react with oxygen to form a thin layer of aluminium oxide. Okay, and that oxide layer, aluminium oxide layer, will prevent the metal from further oxidation and it prevent them from corrosion. So here there are oxygen in the atmosphere. Coating of this layer is coating of oxygen atom, and we have aluminium atoms. Okay, so in aluminium, magnesium, zinc, etc. there is layer of, okay, there is a thin layer of oxide which protects these metals from oxidation with or from reacting with the oxygen present in the atmosphere, and that is why this magnesium, aluminium, zinc they have slow oxidation. Okay, the outer aluminium atoms react with oxygen in the atmosphere. This forms a thin layer of aluminium oxide on the metal surface which protects the metal from corrosion. Okay, so you will observe that these metals they undergo corrosion more slowly, or corrosion does not take place. It is because the aluminum atom at the outer surface will react with oxygen in the atmosphere and form aluminium oxide layer. Now once this oxide layer is formed, this layer will protect the other aluminum atom to come in contact with the oxygen in the atmosphere, and hence oxidation does not take place and prevents the metal from corrosion. So potassium and sodium they undergo rapid oxidation. They react vigorously with air. Aluminium and magnesium they undergo slow oxidation. Gold and silver, okay, gold and silver, do they react with oxygen or do they react with air? Yes, students, let us find out. Okay, so here gold and silver they do not react with oxygen, so there is no oxidation. Okay, so remember this, students. Potassium and sodium they undergo rapid oxidation. Aluminium and magnesium they undergo slow oxidation. Gold and silver they undergo no oxidation. There is no oxidation with gold and silver. Alright, students, we have another question. Please get your rough devices ready. The question is, sodium is stored in kerosene oil because, okay, I'm giving you 30 seconds for this question. Your time starts now. Sodium is stored in kerosene oil because option A is kerosene is a good solvent. Option C, kerosene is easily available. Option B, kerosene oil is better than water to store sodium. Option D, kerosene prevents sodium to come in contact with oxygen or moisture. Yes, students, which of the following option is the correct answer? Alright, students, your time is up, and yes, very good. The correct answer here is option D, that is kerosene prevents sodium to come in contact with oxygen or moisture, and that is why sodium is stored in kerosene. It is because sodium is a very reactive metal, it undergoes rapid oxidation, it reacts vigorously with air. So in order to protect the sodium, okay, they are stored in kerosene. It is because kerosene prevents sodium to come in contact with oxygen or moisture. Very good, students. Alright, students, so we have here silver and gold. Yes, silver and gold do not react with oxygen even at high temperature. Okay, silver and gold do not react with oxygen even at high temperature. So here we can say that potassium and sodium undergoes rapid oxidation. Aluminium and magnesium undergoes slow oxidation. They react, okay, so potassium and sodium, they undergo rapid oxidation, meaning they react vigorously with oxygen. Aluminium and magnesium, they undergo slow oxidation. They react with oxygen slowly, okay. And gold and silver, there is no oxidation, meaning they do not, gold and silver, they do not react with oxygen. So different metals react with oxygen at different rate. Okay, here we see that sodium and potassium, they react with oxygen very fast, rapidly. But gold and silver, they do not react with oxygen at all. Magnesium and sodium, they react with oxygen slowly. Okay, so different metals react with oxygen at different rate. So here we have copper vessel. It turns to dull color, it changes its color. It is because aluminum, when it is kept outside, it reacts with oxygen, okay, to form aluminum oxide. Okay, so here the color changes because aluminum oxide is formed at the outer layer. But when you wash it again, you see that the copper vessels become shiny. It is because you are washing off the aluminum oxide layer, okay, which is formed on this vessel. Now when you wash this off, then again you will see the shiny layer of aluminum vessel. Here we have iron gate. It turns rusted. Yes, so here iron reacts with oxygen to form ferric oxide or rust. Ferric oxide is also known as rust. So here, because the iron gate is reacting with oxygen, it becomes rusted. Because it forms ferric oxide, it is rusted. Okay, now let's come to anodizing. So what is anodizing? Okay, let us see what is anodizing. So anodizing is a process of forming a thick oxide layer of aluminum. Okay, anodizing is a process of forming a thick layer of aluminum. So aluminum develops a thin oxide layer when exposed to air. This aluminum oxide coat makes it resistant to further corrosion. So remember this term, students. Anodizing is a process of forming a thick oxide layer of aluminum. Aluminum develops a thin oxide layer when exposed to air, and this aluminum oxide coat which is formed at the outer surface makes it resistant to further corrosion. Okay, now let us see another example. Here we have copper. Okay, what happens when copper is heated? We see that it changes its color. Yes, copper is brownish red in color. When it is heated, it turns to black color. It is due to the formation of copper oxide. Okay, so when copper reacts with oxygen, it forms copper oxide. So we have chemical reaction, that is 2Cu plus O2, it gives us 2CuO. Okay, so when copper reacts with oxygen, it gives us copper oxide, and this copper oxide is black in color. Okay, again we have here iron filling sprinkled on burner. So iron does not burn on heating. Okay, iron does not burn on heating, but iron fillings burn vigorously when sprinkled in the flame of the burner. Okay, iron does not burn on heating. The iron fillings burn vigorously when sprinkled in the flame of the burner. Nowadays, okay, we have these firecrackers. Yes, and this burns, it is because they are filled with iron fillings, which burns, okay, vitally when sprinkled into the flame. Okay, so here also we see that the sprinkles, the fillings of the iron are burning vigorously, and that is why we are able to see them sprinkle. Okay. Alright students, we have another question. Please get your rough devices ready. The question is, the electrolytic process of forming a thick oxide layer on aluminum and its alloys is called which of the following? Giving you 25 seconds, your time starts now. The electrolytic process of forming a thick oxide layer on aluminum and its alloys is called, option A is calcination, option B is anodizing, option C is oxidation, option D is plating. Yes students, so the electrolytic process of forming a thick layer of aluminum on its alloy is called which of the following? Alright students, your time is up, and yes, good. The correct answer here is option B, that is anodizing. Okay, the electrolytic process of forming a thick oxide layer on aluminum and its alloys is called anodizing. Alright students, again we have burner here. Let us see. Okay, so magnesium ribbons. Okay, take a magnesium ribbon, and when we burn magnesium ribbon, we will get the product. Yes, the reactants are the magnesium and oxygen, and the product is the magnesium oxide. Now, take the product, that is the magnesium oxide that is formed and dissolve it in water. So we get magnesium hydroxide. Okay, we get magnesium hydroxide. So let us test the basicity and acidity. Okay, so when we take red litmus paper and test this solution, what do we observe? We observe that the red litmus paper changed to blue. Now when the red litmus changed to blue, it means that the solution is basic. Yes students, if the blue litmus paper changed to red, it means it is acidic, but if the red litmus paper changed to blue, that means the solution is basic. We have discussed this in acids, bases and salts chapter. Yes students, so the solution here is basic. So metal oxides are basic in nature. Okay, remember this, metal oxides are basic in nature. Now take sulfur powder. Okay, sulfur is a non-metal. Okay, take a sulfur powder in a test tube and let us collect the sulfur dioxide. Okay, so when you burn sulfur powder, okay, under burner, take water in another test tube and connect this to test tube. Okay, as shown here. Now when you burn sulfur powder, it will form sulfur dioxide. Now we see that the sulfur dioxide is being transferred to the another beaker containing water. So when this sulfur dioxide reaches this, we will get sulfur dioxide solution. Yes students. Now let us, so we have sulfur dioxide in water. Let us take this solution and test it. So when we take red litmus paper, we see that there is no change in red litmus paper. There is no color change. But when we take blue litmus paper, see that blue litmus change to red color. So what can we conclude from here? We can say that the solution is acidic. Here sulfur dioxide is sulfur is a non-metal. So we can say that non-metals oxide are acidic in nature. Okay, so remember students, no metals oxides are basic in nature and non-metals oxides are acidic in nature. Most metal oxides are insoluble in water. Okay, most metal oxides are insoluble in water, but some of the metal oxides dissolve in water to form alkalis. Okay, most metal oxides are insoluble in water, but some metal oxides dissolve in water to form alkalis. Let us see some examples. We have here sodium oxide. Okay, it dissolves in water to give sodium hydroxide, which is an alkali. Potassium oxide dissolves in water to give potassium hydroxide, which is also an alkali. Okay. Alright students, so here we see a group of animals. Some animals are living on land, some animals live on water. Yes students. And here we see a frog. Yes. So here we see that the frog, and we have also learned that the frog lives both on water and on land. So what are they called when they live both on plants and when they live both on water and land? We call them amphibians, right? So similarly, okay, just like that case, some metal oxides show both acidic and basic behavior. Okay, we have discussed that metals oxide are basic in nature and non-metals oxide are acidic in nature. However, some metal oxides, they show both acidic and basic behavior. Okay, so let us see here. Acids, when it reacts with base, it gives salt and water. So aluminium oxide, when it reacts with HCl, which is an acid, it gives salt and water. Aluminium chloride and water. So aluminium oxide reacts with acid to give salt and water. So meaning this aluminium oxide is basic in nature. Because when acid reacts with base, we get salt and water. Here also we are getting salt and water. So if HCl is acid, this must be base. So here in this case, aluminium oxide is basic in nature. Again, aluminium oxide, when it reacts with sodium hydroxide, it gives sodium aluminate and water. Aluminium oxide, it reacts with base to give salt and water. Yes, again, acids plus base is salt and water. We are getting salt and water. However, NaOH is a base. So this is base. Then this must be, aluminium oxide must be acid. Yes, because acids plus base will give us salt and water. So in the first case, this aluminium oxide is, it shows basic behavior. However, in the second case, it shows acidic behavior. So we see that these metal oxides, they show both acidic and basic behavior. So metal oxides, when react with both acids as well as bases to produce salts and water, are known as amphoteric oxides. Okay, or you can define amphoteric oxides as those oxides, okay, which show both acidic and basic behavior. Okay, so remember this term students, amphoteric oxides. Metal oxides which reacts with both acids as well as bases to produce salts and water are known as amphoteric oxides. Okay, examples are aluminium oxide, zinc oxide, etc. Reactivity series of metals, okay, based on their reactivity towards oxygen, based on their reactivity towards oxygen. So let us see. So potassium and sodium, they react rapidly with oxygen, right? So they are highly reactive with oxygen. Magnesium and aluminium, they are less reactive with oxygen. And silver and gold, they do not react with oxygen, or they are the least reactive. Okay, so based on the reactivity towards oxygen, potassium and sodium are highly reactive. Magnesium and aluminium are less reactive, and silver and gold are least reactive metals towards oxygen. Recall, okay. So here we have seen that metal, when it reacts with oxygen, we get metal oxide. Examples are aluminium, when it reacts with oxygen, we get aluminium oxide. Sodium, when it reacts with oxygen, we get sodium oxide. Then we have seen that most of the metals are not soluble in water. The next point we have discussed is some metal oxides are amphoteric in nature, that is, they behave both as acid and a base. Okay. The fourth point is different metals react with oxygen at different rate. We have seen that potassium and sodium, they are highly reactive with oxygen, whereas gold and silver, they are least reactive. Magnesium and aluminium, they are less reactive. So different metals react with oxygen at different rate. The fifth point is few metal oxides are soluble in water to form alkalis. Example are sodium oxide reacts with dissolve in water to form sodium hydroxide, and potassium oxide dissolve, or it's dissolved in water to form potassium hydroxide, which are alkalis. Okay, example: sodium oxide and potassium oxide. Okay, all right students, we have another question. Please get your rough devices ready. The question is, which of the following is an amphoteric oxide? I'm giving you 25 seconds. Your time starts now. Yes, students, which of the following is an amphoteric oxide? Option A is magnesium oxide, MgO. Option B is aluminum oxide. Option C is potassium oxide, and option D is sodium oxide. So which of the following option is the correct answer? Alright students, your time is up, and yes, very good. The correct answer is option B, that is aluminum oxide. This aluminum oxide, it shows both acidic and basic behavior. It also acts both as an acid or a base, and that is why aluminum oxide is an amphoteric oxide. Very good students. Alright students, let us see here. So which of the following metals is the most reactive? Okay, which of the following is most reactive? I'm giving you 25 seconds for this question. Your time starts now. Which of the following metals is the most reactive? Option A is sodium, option B is potassium, option C is iron, and option D is silver. Yes students, which of the following option is the correct answer? Alright students, your time is up, and yes, very good. The correct answer is option B, that is potassium. Okay, the most reactive metal is potassium. Action of water on metals. Okay, so let us see action of water on metals. Reaction of sodium with water. So what happens when sodium reacts with water? Okay, so take a beaker of water. Okay, and here we have some sodium metal in kerosene filled petri plate. Okay, so these are the sodium metal in a petri plate filled with kerosene, and this is cold water. What happens when sodium is put into the water? You will see that it reacts rapidly, vigorously with the water, and it exploded. Yes, it produces flame, it produces large amount of heat, and it exploded. Yes. So sodium, when it reacts with water, it produces sodium hydroxide and hydrogen gas. Okay, sodium, when it reacts with water, it produces sodium hydroxide and hydrogen gas, not hydroxide. Okay, hydrogen gas. So here we see that the flame is produced, large amount of heat is produced, and it catches fire. The sodium metal, it catches fire when it reacts with metals. So sodium in water, we have this. Okay, so sodium reacts with water to give sodium hydroxide plus hydrogen gas plus heat energy. It produces large amount of heat. Okay, so this is another example, potassium in water. Potassium, when it reacts with water, it forms potassium hydroxide, and it gives hydrogen gas and also produce heat energy. So it will also produce flame. Okay, it will also burn. So sodium reacts with water to give sodium hydroxide plus hydrogen gas plus heat energy. Potassium also reacts with water to give potassium hydroxide and gives off hydrogen gas and heat energy. So potassium and sodium react violently with cold water. Okay, this reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. Okay, the potassium and sodium reaction with water is so violent and exothermic, it produces heat it evolves heat, okay, that the evolved hydrogen immediately catches fire in this reaction. Action of water on metals, we have reaction of calcium with water, cold water. So what happens when calcium reacts with water? Let us see. Add some pieces of calcium into cold water. Hey students, what do we see here? We see that it is reacting. Yes, and after some time you will see this white color solution is formed. So note down, okay. Calcium, it reacts with water to give calcium hydroxide and hydrogen gas. Reaction of calcium with water is less violent, okay, than reaction of water with sodium and potassium. Alright students, we have another question. Please get your rough devices ready. The question is, what happens when a pellet of sodium is dropped in water? Okay, I'm giving you 30 seconds for this question. Your time starts now. What happens when a pellet, okay, or when a piece of sodium is dropped in water? Option A, it catches fire and form oxide. Option B, it absorbs heat and form oxide. Option C, it catches fire and form hydroxide. Option D, it absorbs heat and form hydroxide. So which of the following option is the correct answer? Alright students, your time is up. Let us see. When sodium or when metal reacts with water, it does not form oxide but it forms hydroxide. So we can eliminate these two options. It does not form oxide. Okay, it forms hydroxide. Now which of these option will be true? Option C or option D? It catches fire and form hydroxide. Option D is it absorbs heat and form hydroxide. Yes students, very good. We have seen that when sodium is dropped in water, it catches fire, yes, and form hydroxide. So here the correct answer is option C, that is it catches fire and form hydroxide. Alright students, so in our today's class we have discussed some chemical properties of metals. The first is when metals react with oxygen, they form metal oxide. Yes, that is the first point that we have discussed in today's class. We have seen that potassium and sodium, they undergo rapid oxidation, whereas magnesium and aluminum, they undergo slow oxidation, and gold and silver, they undergo no oxidation. We have also seen anodizing. What is anodizing? Anodizing is the process of forming a thick layer of aluminum oxide, and this oxide layer which is formed protects the metals from further corrosion. We have also seen that metal oxides are basic in nature. Most metal oxides are basic in nature, and non-metal oxides are acidic in nature. However, we have seen that some metal oxides, they behave both as acid and a base. Yes, so those oxide which behaves both as acid and base are called amphoteric oxide, and some of the examples of amphoteric oxide includes aluminum oxide and zinc oxide. We have also seen the reactivity series based on the reactivity of metals towards oxygen. Yes, we have seen that potassium and sodium, they are highly reactive with oxygen. Magnesium and aluminum, they are less reactive with oxygen, and gold and silver are least reactive with oxygen. Okay, we have also seen the action of water on metals. Yes students, we have seen that sodium and potassium, they also react violently with water to form metal hydroxide, and calcium, they reacts with water but to form calcium hydroxide, but the reaction between calcium and water is less violent as compared to sodium and potassium. Now we have also seen that sodium and potassium are stored in kerosene oil. It is because they are highly reactive. So in order to protect them, okay, from coming in contact with the moisture or air, they are stored in kerosene oil. So these are some of the points that we have discussed today. Okay, reaction of metals with oxygen, reaction of metals with water. Okay, so in our next class we will discuss more on the chemical properties of metals. So I hope you learned something from today's class. This leads us to the last question for today. Please get your rough devices ready and respond to this question. The question is, how do you feel about today's class? Okay, I'm giving you 10 seconds. Your time starts now. How do you feel about today's class? Please give your feedback about today's class. Alright students, your time is up. Thank you so much for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.